assignment for the mid part of ME 362 says for the two flows given by phi of x comma y is equal to arc tan of y over x, and phi of x comma y is equal to x squared plus y squared. We are asked to 1, determine the velocity field, 2, determine the volume flow rate. The first question in the assignment is for two flows given by psi of x comma y equal to arc tan of y over x and phi of x comma y is equal to x squared plus y squared. We are asked to determine the velocity fields and sketch the streamline. We are also asked to determine the flow rate through the cycle of radius r, flow rate q. We are also asked that which of the flow is not feasible to set up in the lab, not feasible to set up in the lab. So we proceed as follows. Okay, so we proceed as follows. Phi is given by arc tan of y over x. So if I find the derivative with respect to y, remember that the streamline is the velocity component u is given by as to psi to y and b as minus to psi do x. So if I solve, I would have do psi do y as x over x squared plus y squared by differentiating tan inverse of y over x. That's the result with respect to y. And also if I differentiate do psi do x with respect to x, I would have y over x squared plus y squared of this function. So when I differentiate with respect to y, I get this function, and when I differentiate with respect to x, I get this function. So imputing it into the velocity equation, we would have that u is equal to psi do y, which is equal to x over x squared plus y squared, and v is equal to minus the side dou x, which is equal to y over x squared plus y squared. Hence, and here has a minus sign, obviously. So if I come here, I can now attempt to draw the streamline. The streamline, which is given by psi, is equal to arctan, that is tan inverse of y over x is equal to a constant theta, so that the streamlines become of this form. And we can say that the magnitude of the velocity field varies as 1 over r. While for the second flow, we have the following. Psi is equal to x squared plus y squared. So u component is dou phi dou x, and in this case is equal to 2x, and v component is dou phi dou y, and in this case is equal to 2y. Therefore, the velocity field is equal to the component of u and the component of v. So if I want to write the streamline, recall that streamline is equal to dy dx, which is equal to v over u, and in this case v over u is equal to y, that is 2y over 2x, which turns out to be y over x. So now I have the streamline function, and then I can solve for y from here. Solving for y, we have dou y over y is equal to dou x over x. This is from separable variable. Hence, we can say if I integrate both sides, I would have y to be equal to c of x. C times x. y is equal to ln x plus c, right? That's what we'll get. So if we obtain this, we would have y will be equal to cx, because since ln of x plus ln of c is equal to ln of cx, which means that ln y is equal to ln cx, which implies y is equal to cx. Okay. For the b part, we are told to find the flow rate v dot or q dot. V dot is given by 2 pi r ur. Now, we know for the first flow that u is equal to x over r square, which is equal to cos theta over r, and v is equal to xy over r square, which is equal to sine theta over r. It's r square because the radius is given by the square of x and y, the sum of the square of x and y. So we have r square representing that, with x remaining there, and for the v, y remains y, x squared plus y squared was equal to r squared. So now, we can write further that u of r is equal to u sine theta equal to u sine theta plus u cos theta plus v sine theta, and is equal to 1 over r. And this ur represents radial velocity. Hence, I can say that v dot, which is equal to 2 pi r ur, is equal to, in this case now, ur becomes 1 over r times 2 pi r, and that's equal to 2 pi. So this is the flow rate, and it's a constant, and it's equal to a constant because it doesn't vary with anything, not varying. Next, for the next flow, we have that phi is equal to x squared plus y squared, which means u was, and we got u to be 2x and v to be 2y, and x equal to r cos theta, while y is equal to r sin theta. So if I plug this into the equations, we are going to have that ur is equal to u, which is 2r cos theta, and v, which is 2r sin theta. ur being u cos theta plus v sin theta. So, okay, before we go on, let me give you some important tips to note. Now, we know that if we have the coordinate system like this, we know that y and x, and this is our r, and this is theta. and we can write it for UV, U and V, and this is radial UR. Okay, so recall that it has been noted that U of R is equal to U cos theta plus V sin theta. So now, if I should represent U to be equal to 2R cos theta and V to be equal to 2R sin theta, and plug it into the equation UR is equal to U cos theta plus V sin theta, we are going to have 2R sin square theta plus cos square theta. And this is obviously equal to 0 from trigonometric identity, Hence, we can write that the volume flow rate is equal to 2 pi r UR is equal to 2 pi r into 2r, and that is 4 pi r squared. The part C tells us, and of course we can see that the velocity in this one varies with the increases with r squared. The final question says, which of the flow is not possible to set up? So to find that out, we have to find that the diff, for a flow to be possible, it has to obey the continuity, the mass conservation stroke continuity law. Hence, and that law is that the divergence of the velocity vector v is equal to 0. So we test it for both flows. Say and to find divergence, you are going to get the differential with respect to x plus differential with respect to y. I can therefore say for phi equal to x squared plus y squared, differential with respect to x, dou phi dou x is equal to 2x, and dou phi dou y to 2y. Then, if I sum them up, 2x plus 2y is not equal to 0. Hence, this flow is not possible. Let's test the other equation. We got from that equation that the velocity field was equal to x over x squared plus y squared plus y over x squared plus y squared. Okay. So let's differentiate this with respect to x and y and see if they sum up to give 0. So x squared, y squared plus x squared plus y squared, x rather, so differentiate with respect to x, I will have ln of x squared plus y squared times 2 and then for the other one, I would have for y, I'll have 2 ln of x squared plus y squared. Of course, sorry, there's a negative sign here for y. That's v equal y over x squared plus y squared. There's a negative sign here, so this becomes negative here. So if I sum these two flows, I'm going to find out that 2 ln of x squared plus y squared minus 2 ln of x squared plus y squared cancels out and equals 0. Therefore, we can say that flow one is possible, can be set up in the lab. Flow 2 is not possible. Thank you for watching.